Have at it. Tell us about it.
Well, this is a follow-up to Chris's presentation on Trans-Oceanic radios that he did several months ago. I was slated for doing the meeting in July, but it just so happened that BARS met the second Monday and the JAWS Club meets the second Monday, and since I'm the president of JAWS, it took priority over this. So I'm back now. Hopefully nobody's forgotten anything from the first sessions. But what this one's about, Chris is telling about the breadth of the models and the years that they're in, and what I'm going to touch on is repairing these. Over the course of several years, I've done probably close to 100 of these, and they're just something that's kind of a passion, and if anybody wants to take a look at the guts, we'll just pass that down around. You drop it or punch a hole in it. It's a hanger. That's right. Yeah. That's right. These are very elegant and simple radios and easy to operate. If you feel comfortable with tubes, it's good. It's a good one to get your teeth in and get your first restoration experience. If you're not familiar with tubes, there's lots of books like the Radiotron Designer's Handbook. It's all about tubes and free online. Now, I don't have a little clicker, so I'm just going to have to wing this. And I'm not going to read these slides. You can see them. This is what we're going to cover tonight. And if I get in your way, just kind of hiss at me or something. If you get bored, kind of shut your eyes or something. I'll catch you. These are from the 50s era. They started out, actually I'm only going to focus on two models, the 500 series and the 600 series. There's a whole slew of them beforehand that kind of evolved into these. The 500 and 600 are multi-band radios, so they capture everything from about broadcast band up to 18 megahertz. What's unique about them is the shortwave listening bands, they band spread instead of just having them compressed into a continuous space. And the first one I ever encountered was one my dad had in the 50s, and it kind of got me interested in listening to shortwave radio, and I don't know whatever became of it, but one thing I can remember clearly is it had a real musty smell because it was in our basement, and the one on the end that I've restored for myself as my personal keeper has that same musty smell. I don't know how it got there, but it's there. This is your early 500 model. It has kind of a classic Zenith dial, like you'd see on many of the black-faced Zenith radios of its era. And the 600 series, they went to a slide rule type of dial. In the bands, up on the top is a logging scale, and then there's 4 band-spreaded bands, the 31, 25, 16, and 19 meter bands, and then down below are some of the bands in the 6, 5, 9 megahertz range. The series started out with the G500 and the H500, and then there was a really unique one that was a military radio that was used for entertainment, and they're extremely rare. If you find one of those radios today, they're $300 to $500. But the beauty about the R520 is our tax dollars created a manual. It's about 100 pages. That's the best manual out there for understanding the theory and technology that's used in the Trans-Oceanic line. And there's quite a bit of similarity through all the different models. These radios were the first of the Trans-Oceanic line to use miniature tubes, and they made a lot of them, up in the, I don't know, several 100,000. Chris, you probably know the total numbers of them, but there's a lot of them to be had. This is where you find them, everywhere you expect and least expect to look. I picked up an old crappy one at Restore. It was kind of a surprise to see one there. In fact, it might have been this chassis that's floating around.
You're extremely lucky that Brad and I didn't beat you to it then, because we go to Restore a lot.
Oh, okay. I have several chassis around that are like that are parts donors, and that one probably could be restored. It's in pretty decent condition, throw some tubes in it, and do some basic restoration, and it'll probably come right back to life. These are what you look for when you're buying, and they're what you expect out of something that's 60 years old. The most critical is that 1L6 tube and the ballast. If you don't have those, plan on spending $25 to $50 just buying those two tubes. The ballast you can substitute with a resistor, so it's not as critical, but the 1L6, that's kind of a deal breaker. If it's a radio that doesn't have that, start talking it down, because it's going to be expensive to find that tube. 25 is a mean price today. You can find them anywhere from $5 to $50. There's lots of resources out online, and if you're interested in these, I'd be glad to send you the presentation slides, and you can go out to these URLs and find a lot of follow-up information. If you're interested in the tech manual, I'd like to say I could email it to you. I'll find you a link to it. It's about 22, 24 megs, and most mailers won't accept attachments that large. But it's out there, it's free, and easy to have. And if you go to any of these sources, you can find all kinds of information about them. Suppose you pick up a B600, which is one of the last models. The SAM's PhotoFax are commonly available. You can buy them, or you can find them online, or shoot me an email and I'll send you a copy of one for that particular receiver. The nice thing about the PhotoFax is they come with all the very specific alignment detail and repair detail, schematics, and parts lists. The Army technical manual, on the other hand, like I said, it was paid for by tax dollars, and it's a generous treatise on the subject of Zenith radios. They were used in the military, and they're quite a bit different than the civilian models in that they're meant to work on multiple voltages. They had some extra refinements to make them, I guess, more field usable. But the basic principles and operation of the radio are identical. These are the SAMs, and if you're familiar with SAM's PhotoFax, during the heyday of television tube radio, SAM's produced manuals for every television set, every radio, I think CB radios, and probably all kinds of other devices. The circular radio is a basic 5-tube radio. It's sort of like your all-American radio. From, if you remember when you were kids, you had the little AM radio, had 5 tubes in it. Very similar. It's got an RF amp, it's got a mixer, an IF amp detector, and audio output stage. What's kind of unique about it, though, that differentiates it from the all-American 5s, are the tube voltage. If you notice, there are 1 volt and 3 volt tubes. This set was meant to run on batteries as well as the AC line. And in a typical all-American 5, if you add up all the filament voltages, they equal about 120 volts, so they could live on the AC power line without a transformer. These are all 1 volt tubes, and the power supply creates a DC filament voltage for the tubes that are all series together. How many read schematics? Everybody? This is very simple when you look at it. The RF stage and the first converter, and I'm showing it for the broadcast band because they do some switchery to move coils in and out. It uses a loop antenna on top called a wave magnet for the broadcast band, and you can connect an external antenna on the left-hand side. One of the hazards of any AC-DC radio is that without a power transformer, that chassis sometimes can be hot. You ever been shocked by one? First time I remember, I was barefoot in the basement and I touched that. I came away quick. It still has a buzz that gets to me today. You can hook an antenna to this radio, but it's probably ideal to have an additional capacitor external to the terminals and a capacitor to ground and not timed directly, especially if you haven't restored it. If you have restored it and you've replaced all the paper capacitors in it, you'll be somewhat assured that nothing dramatic will happen when you connect an antenna. I have seen sparks fly. Well, the shortwave bands use a slightly different setup in the front end. They switch in and out coils in the RF stage and the converter stage. There's the RF, the converter, and the output of the mixer. And one of the restoration difficulties that almost everybody will encounter, there's a series of 7 push-button switches on the front. These contacts get dirty, and even if you carefully clean them, if you let the radio sit for 6 months or a year, they get a little bit scratchy, and you kind of have to go through an exercise of punching all 7 switches maybe a dozen times each, and they'll come back to life. Because the switching is so complicated for the bands, there's a lot of points there that you can have problems with. When I restore a set like this, one of the first things I'll do is try and clean the contacts with alcohol and a spray, and then use a contact cleaner like Deoxit or one of the others to brush on to keep the contacts clean. Because the switch wafer is all phenolic, you don't want to just spray it liberally with Deoxit. It makes phenolic swell, and that can cause you switch problems in the future. So clean it up now, but later on it'll cause issues. The IF amplifier is very, very straightforward. There's one stage with 2 transformers. This radio is broad as a barn. It's easy to hear 3 stations at once. I say that like in the broadcast band where there's a lot of them very, very close together. In the shortwave bands, depending on how strong the signals are, it's selective enough that it can give you high fidelity reception, but it's not selective enough to sort out stations easily. The good thing is that they're not that sensitive, so you don't have a tremendous amount of stations to sort out, especially with a whip antenna. When you hook up an external antenna, it can get a little bit annoying because you hear many more stations on the set that's capable of selecting out. I do have one set at home that I purchased a board from a company called Kiwa that has multiple ceramic filters on it, and put it in there just to see how well it would behave with a 6 kilohertz filter and a 4 kilohertz. It does make a difference. It makes it a little bit easier to tune around on the broadcast bands. If there's any questions, just yell. If I'm ignoring you, I really am not. I'm trying to go through this kind of quickly to meet my time limit. The detector and audio output stages are fairly conventional, and something I'm going to point out to you, these tubes don't have cathodes like traditional 6-volt sets do. The filament acts as the cathode, and that causes kind of a unique problem in the strings when you're trying to design a radio set like this. And I'm going to skip ahead. The next stage, biasing each of the tubes is a trick that Zenith had to come up with. And even though the tubes are all connected together in a series string, as you can see, they went to a great deal of difficulty to apply the correct bias voltage to make each of the tubes work. That's not a problem. Seldom do you see any issues in the bias string, but it is something to kind of be aware of when you're troubleshooting the set, that if you're measuring grid voltages with a high impedance meter, they'll wander around a little bit. Going back, the tone control circuit is really unique, very unique. They designed this set for entertainment like audio, and even though it doesn't have watts, it may have half a watt of output. What they've developed in this set is a negative feedback circuit that goes back to the first audio stage, taking a piece of the audio off the output transformer, and you're able to change the gain at certain frequencies. You can listen to treble on news programs. You can listen to bass on music programs, or when the atmospheric noise is kind of high. And any combination, you can kind of work them back and forth to get it to sound the way you want it to. The filament string, they start out with the AC power line on the left, the power source, and one of the power supply adapter receptacle, if you look inside the radio and on the end of it, you'll notice the AC plug is plugged into a little slot in the side of the radio. When the folks had batteries using these radios, you would plug the AC plug into that side slot, and that cuts in the battery and cuts out the AC power supply. That kind of turns on the battery sources. The filament supply to keep the noise down from the AC power line is rectified and it's DC. And if you notice inside the square block, there's 4 electrolytic capacitors. You always replace that. That's invariably after 60 years dry and ineffective. The military version has shown a fuse in the AC line circuit. None of these have fuses, but part of the restoration process is to solder a 3/8 amp fuse in it to offer a little bit of protection. The tube that says RT1 that looks like a variable resistor is what's called a ballast tube. And what that does is that allows for variations in line voltage and makes the radio set have somewhat high current starting up. The tube's getting them warm, and then once they get up to their operating temperature, it settles down to a lower voltage to keep them constant. And it's like a transistor radio. Flip it on, and within 50 milliseconds, it's playing. That was the nature of the beast and the filament string for it. The power supply is very, very simple. It again, power comes in from the AC line where it says plug, and through what's called CR1. That's a selenium rectifier. Selenium rectifiers were early diodes that were developed in the 40s and 50s. And what they look like is a whole series of heat sinks, plates that are put together. That is the first thing next to capacitors that you replace in these radios, because I tell you what, when you have a fault in the radio and that thing goes up in smoke, it's noxious. It's horrible smelling. And so replacing it with a simple high voltage silicon diode is one of the first things. The second thing is the paper capacitors in the radio. And so if you get one of these radios and you're tempted to turn it on, do something like put a light bulb in series with it or bring it up on a variable voltage supply and make sure it doesn't go up in smoke. The most sane thing to do is to take the radio, not turn it on, just take the chassis out, like they have in front of them, go through and change all the paper capacitors, and they're the plastic ones that look like bumblebees. They have, they're typically called black beauties or black beauties of death. They don't last long, and if you look at them carefully, you see a lot of cracks in them where they've gotten hot and overheated. And then the third thing you replace is the electrolytic capacitor. Once you do that, it's pretty much ready to turn on and see how it's doing. If it doesn't come up after that, you may or may not have a tube issue with a filament, and you can either drop the tubes in your tube tester or trace along the pins and find out if there's current flowing from tube to tube. This I can't stress enough. These radios, as nice as they are, they'll shock you. They will shock you good. And it's every time I get shocked, it's a surprise. I thought I knew better, but I guess I did. When you're repairing them, you need to use an isolation transformer. And what that does is that lifts the AC line off the ground, makes the radio independent of the ground. And if you don't have an isolation transformer, one of the easiest things to do is to buy a couple of filament transformers, say like 6.3 volts at 12 amps, timed back to back. You have 115 coming in one side, 6.5 coming out, 6.5 coming in, and 115 out the other side. And you can isolate them above ground. That allows you to use your test equipment on them without any kind of dramatic event like sparks and other things happening.
Hey, Bill, what would be the power rating of these little transformers back then?
25 to 30 watts max. There's very little power.
Walmart's wouldn't work. I mean, the
Wallwarts? No, because, 12 volt is 12 watts and an amp. The best thing to do is if you can find some like Radio Shack filament transformers or anything you happen to have around. Sometimes you can find isolation transformers fairly easily at hand presses. There's no
doorbell transformer.
What's that?
Doorbell transformer.
Well, if you had, well, no, I don't think it'd be stout enough. It probably takes a transformer with about 2.5 to 5 amps of winding, secondary winding back to back to function as an isolation transformer. This is a simple designation to help you understand the isolation transformer concept. Instead of carrying through neutral to the radio, and one of the hazards being when you plug it into the wall, as you know, there's a hot and a neutral, and the plug is non-polarized. So when you plug it in, the chassis will either be hot or at neutral, you don't know. So if you use an isolation transformer, you can avoid the excitement of putting a ground from your signal generator on the chassis and watching it happen. What's that?
Takes everything with it.
Yeah.
I found voltage on the neutral side too, so
What's that?
I have been working on old radios that have neutral side with voltage on them too.
I mean, the chassis is at neutral.
Now, the neutral is a little bit hot, not a whole lot, just a little bit from the AC current.
A
that's
lot of
going on.
older radios, either AC/DC or even transformer style radios, will have a pair of capacitors from each side of the line to the chassis. But that puts the chassis about 60 volts above ground, and that will,
Yeah,
they'll wake you up.
that's about what it does. Didn't shock me. I didn't touch it. I looked at it with a meter.
These are the tools that I recommend for having, for doing restorations, and it starts from about the cheapest to the most expensive. And something characteristic about this is you will use the least expensive tools the most, and the most expensive tools least. And the time you need an oscilloscope is about probably 1 in 100 that you use a DVM. You drag out the oscilloscope or spectrum analyzer when you truly have a problem. You can't solve it with simple means. But a good DVM, even something you buy at Harbor Freight, is enough to work on this, because we're not talking about precision electronics. It's very simple. These are essentially what needs to be replaced in a transoceanic. I've already talked about some of them up in the front, the first 5. Adding a fuse, sir.
You'd be able to replace the selenium rectifier with a 1 in 5,007?
Yeah. Because they're like 2 cents a piece.
Well, okay, 1 in 4,007 is like a 600 volt 1 amp rectifier.
5,000 would be 1,000 PIV, and
I think you mean a 4,007. That's a
Maybe I do.
1,000 volt PIB 1 amp.
okay. You want to replace it with a cheap diode. The selenium's going to fail. You don't know when, but why have it fail in your house and smell up your house? The 9 volt Zener diode is something that I do to all of these. The 1L6 costs $25. A 9 volt Zener diode that's 5 watts.
That's a pretty good price.
Well, if you can get it, yeah. A Zener diode's $1 or less. So strapping one of those across a filament supply, it'll shun anything. If something, if it gets too high a voltage, you'll just shun it. And if it gets really high, it'll blow the fast flow fuse and you won't have a problem. And in some radios, this one's not one of them, I'll install an isolation transformer in the radio. Either one transformer that's 110 to 110 or back-to-back. And there was one radio I did for somebody where they wanted a battery eliminator, and essentially was an isolation transformer, and the 90 volt side came from the isolated secondary of the transformer, and the filament voltage came from the two 6.3 volt windings that were back to back. And it was nice, but it wasn't necessary. It was somebody wanted to use the battery pack that originally came from it and make it look like it ran on DC. The mechanical restoration is kind of what you expect. All the stuff that needs to be cleaned and lubed, and the case is my favorite, least favorite part to do. A lot of these you get, the fabric's torn, you have to glue it down. If the plastic's cracked, unless you can find good plastic, about all you can do is put a little bit of glue in it, and like methyl ketone or something like that, and make it come together again. Finding knob inserts, that's another thing that seems to be lost, is those little bronze cones. They're available, yeah, I just have to spot them. The lady that comes to the shortwave club, or the antique radio club here in town, that has knobs, what's her name?
Oh, Julie, she lives in Nashville.
Oh, okay. Well, when she comes up here, that was the place to get knobs, you know, and buy everything she had for Trans-Oceanics. Speakers, a lot of times they're torn, and what I think tears them more than anything is when you pick one up by the speaker and put your thumb through it. Little Elmer's glue and some paper, and it's back on the road again. And that's the end of it. Did I make 30 minutes, or?
Yep, well, you got a couple of minutes for that.
Okay.
I'll take some questions.
If there's any questions, answer questions.
The 1L6 tube,
Yes.
is there no substitute for that tube?
Not directly. Some people use a 1R5, but I think the oscillator only allows it to go up to
Yeah,
about
you won't get the high end.
9.
Just doesn't work as well.
Yeah, you won't get up to 18 there.
You know about this too.
Now, there is a way of cheating around. You can use there's an octal 1 volt tube that's exactly the same thing. You can make an adapter and plug it in. But, you know, if you value your time and it takes you an hour to make an adapter, and, you know,
The adapters can also be purchased, but they're not cheap. They're not much cheaper than the tube. Well, there's a guy on eBay that makes them.
Oh,
And I think he's been gradually increasing from about $15 to about $20.
Okay.
I bought one just to have it in stock. But yeah, the one LA6 is dirt cheap, and it's the exact same.
That's right, 1L6.
Exact same tube.
well, the 1L6 can be found. You can find them at Hands Best if you're patient. You can get them for $2, $3, $5, $10. They're around. If you have to buy one online, they're $25 to $39.
Mike mentioned if you spot one of these at a radio meet or something like that, then pop the back open and see if that 1L6 is in there,
That's right.
because it's normally been pulled.
Right. And you want to look for the ballast too.
The ballast,
Not all use the ballast tube though.
They don't. But those that do, you don't necessarily need a ballast. You can put a high wattage resistor in and do the same. But, you know, it's kind of nice to have it if you can get it. They're probably harder to find than the 1L6.
Bill, can we go back to the schematic real quick?
Sure. Which one?
Right there, yeah, the 1U5, V4? What's that other element right above the page? V4, the 1U5, no, that way. Oh,
The 3V4?
no.
No, the leftmost two.
V4.
V4? Oh, okay. What is what element?
All right, it shows like an element right in there just above the filament. What-
Oh, that's not connected?
Yeah.
the diode.
I think because we're talking about the power supply, they're not showing any of the signal circuitry. Let's take a look just a little bit farther up to the RF stage. There they're showing it. This is directly out of the tech manual.
Okay.
And you notice the control grid?
Right.
It's a control screen suppressor,
Yeah.
and then the plate. The control grids are all connected, and I think it's because the other one was trying to have you focus on the power supply and not be distracted by the signal path. And in addition to schematics in the Army Tech Manual, it's got a full treatment of how all the circuits work. And you probably know, tech mans, man, if you can't read one of them, you need to go back to school. They write those for the lowest common denominator, and they're clear, but yet they're not mysterious. Leave a lot of explanation.
Here's something on a solid state replacement for the 1L6.
Yeah, they have those as well. They're as much, if not more, than the tubes themselves.
Yeah, it says retailing for $30.
Plus it's
Well-known
cheap.
supplier.
There's no vacuum in it. If there's no vacuum in it, it's not any fun.
How you gonna know who's right and wrong?
The guy who invented the question.